Hello students, today we'll solve some problems based on Riemann-Stieltje integral, whether the given function is integrable or not. Okay, so this is the first problem. Show that a constant function is integrable on closed interval AB where alpha of x is equal to x for all x belong to closed interval AB. So let f from closed interval AB to R, that is a real valued function f defined by f of x equal to k. See here they are given a constant function, so we are taking that constant as k, and that constant function f of x equal to k. Okay, so let f from closed interval a comma b to R defined by f of x is equal to k for all x belong to closed interval ab be a constant function. Let p equal to x0, x1, x2, etc. up to xn, where x0 equal to a and xn equal to b be any partition of closed interval ab. Let's calculate what is u of p comma f comma alpha and l of p comma f comma alpha, because for us to check whether the function is integrable or not, first we need to check whether the upper Riemann-Stieltje integral is equal to lower Riemann-Stieltje integral. If that happens, then we can say that the function is Riemann integrable. Okay, and for me to find the upper Riemann integral, first I need to find what is u of p comma f comma alpha. So according to the definition of upper sum, I have u of p comma f comma alpha is equal to summation I equal to 1 to n capital Mi into alpha xi minus alpha xi minus 1, which is equal to, see here, this capital Mi is k because each and every member in this interval is mapped to k because it's a constant function. According to constant function, each and every element in the domain maps to this k. So here the range, it consists of only one element, that is k. So whether you take small mi or capital Mi, it is k only. Why? Because this is the only element which exists in the range of f. So here capital Mi is equal to k, and alpha xi is xi minus alpha xi minus 1 is xi minus 1, because here in this particular problem alpha x is equal to x. Okay, so it is k into xi minus 1. And here I can take k outside because this summation is for I equal to 1 to n, and this has nothing to do with this summation. So it is k into summation xi minus 1. And once you apply this summation, that is from I equal to 1 to n, I have at last b minus a, because remaining everything will get cancelled with each other, and at last you will be left with k into b minus a. Okay, so your u of p comma f comma alpha is equal to k into b minus a. And what about this upper Riemann integral? So that according to the definition is equal to infimum of u of p comma f comma alpha, where p is any partition of closed interval a comma b. And here infimum of u of p comma f comma alpha, see here any u you take here, it is nothing but k into b minus a. So the upper Riemann integral is, which is equal to infimum of u of p comma f comma alpha, is equal to k into b minus a. Now let's calculate what is L of p comma f comma alpha in order to calculate what is lower Riemann integral. So that is equal to summation I equal to 1 to n small mi into alpha xi minus 1, and here also small mi is k, and I told you why, because the range consists of only one element, and that is k. So there in that set, whether you take supremum or infimum, okay, that will be k itself, because there is only one element in the set. So k into xi minus 1. Why? Because alpha of x is x, so alpha of xi is xi, and alpha of x minus 1 is x minus 1. So xi minus 1, and once you expand this summation, you will get k into b minus a. And once you calculate this lower Riemann integral, you will get supremum of all L's, but all L will have this value only. So if you take supremum of L also, you will get k into b minus a. And since this upper Riemann integral is equal to lower Riemann integral, the function becomes Riemann-Stieltje integrable. So therefore the constant function is integrable. Okay, so this is how the given constant function becomes Riemann-Stieltje integrable. So now let's move on to next problem. Show that the function f defined by f of x is equal to 0 if x is a rational number, and f of x is equal to 1 if x is an irrational number. Okay, it is not integrable, so we need to show that this function is not integrable on any interval, and here alpha x is equal to x. And see here, let closed interval a comma b be any interval. Okay, and let p be the partition x0, x1, x etc. up to xn, where x0 equal to a and xn equal to b. And according to the definition of u of p comma f comma alpha, it is equal to summation I equal to 1 to n capital Mi into alpha xi minus alpha xi minus 1. And here, actually that is the supremum 1, because whichever interval you take, it consists of both rational numbers as well as irrational numbers. So when you take the supremum of any interval, so that will be 1. And since alpha x is equal to x, I have alpha xi is equal to xi and alpha xi minus 1 equal to xi minus 1. So it is 1 into xi minus 1. And when you sum up all this, you will get b minus a. Okay, and now let's find what is L of p comma f comma alpha, and that is summation I equal to 1 to n mi into alpha xi minus alpha xi minus 1. And whichever value you take, whichever interval you take, there the infimum will be 0. So it is summation 0 into xi minus 1, that is equal to 0. So here the lower, that is L of p comma f comma alpha, whichever L of p comma f comma alpha you take, the value will be 0. And whichever u of p comma f comma alpha you take, that will be b minus b. Whichever u of p means, I just mean whichever partition you take, your upper sum will be b minus a, and whichever partition you take, the lower sum will be 0. So by this way, the upper Riemann integral will be b minus a and the lower Riemann integral will be 0. Why? Because this is the infimum of all u's and this is the supremum of all else. But whichever p you take, the L value remains the same. And whichever p value you take, whichever partition p you take, u value remains the same. So that is how the upper Riemann integral becomes b minus a and lower Riemann integral becomes 0. And since b minus a is not equal to 0, f is not Riemann-Stieltje integrable on any interval. Okay. So this is all about the example based on Riemann-Stieltje integrable. Thank you.